I'm climbing over 300 feet above the River Avon at the Avon Gorge near Bristol. I'm just a small part of what's being suspended from one of the engineering marvels of the Victorian age. This is the Clifton Suspension Bridge.
This is Climbing Great Buildings, and throughout this series I'll be scaling our most iconic and best-loved structures, from the Normans to the present day.
Way.
I'll be revealing the building secrets and telling the story of how British architecture and construction developed over 1,000 years. This time, my journey through Britain's great buildings brings me to Bristol. Completed in 1864, Clifton Suspension Bridge was designed by the most famous engineer of the Victorian age, Isambard Kingdom Brunel. Today, it's the earliest complete surviving example of a suspension bridge anywhere in the world.
When the idea was dreamt up, the Clifton Suspension Bridge was to be the world's tallest and longest suspension bridge, typical bravado in the age we've come to call the Industrial Revolution, and its completion marked a milestone in engineering history. It is more pure engineering than any building we've seen so far, but the materials that it used and the structure it perfected would come to influence architecture well into the 20th century.
In order to get a closer look at this iconic example of Victorian engineering, I've been given unprecedented access to see the bridge from a totally new angle. I'll be climbing out of Brunel's towers to get close up with the Victorian ironwork.
It's amazing, isn't it, how this long after it was dreamt up, it still seems an amazing achievement.
Getting caught in the rain over the Avon Gorge.
It's a tad moist.
And getting a totally unique view of the bridge by dangling 250 feet in the air.
That actually brings home, doesn't it, the audacity of taking on a project like this. 3, 2, 1.
Joining me, as ever, is the Queen of British Climbing, Lucy Creamer. A team of riggers and intrepid all-action cameraman, Ian Burton. To see how the tenacity of a visionary engineer went on to create a structure that inspired modern bridges the world over.
Isambard Kingdom Brunel was only 24 when he entered an open competition to design the bridge in 1831. He called it his first true love, but it wasn't a simple process of construction. It had everything that a Victorian melodrama should have. It had conviction, love, loss, disappointment, and ultimate triumph. It remains today the only substantially complete early iron suspension bridge in the world.
The bridge spans 702 feet across the Avon Gorge, with Clifton and Bristol on one side and Lee Woods in North Somerset on the other. For the first climb, we'll be scaling the bridge's west tower on the Somerset side to see how the structure of this feat of engineering is supported.
Yeah, I'm excited by this. It's one of those, it really is a truly iconic structure. It is about the most perilous position we've climbed in so far. In any normal building, this would be ground level, wouldn't it?
Yeah.
But this ground level is about, what, 300 feet over a gorge.
With this wind and the cars going by, you can actually feel a slight wobble going on.
Well, the bridge does wobble. It's got that expansion joint down there. And, of course, the bridge has to flex.
Right.
It has to give a little bit because it has variable weights on it. You see that wonderful great sweep of iron chains.
Yeah.
It was built top down.
Ah.
So the chains get built first and everything gets hung from it. I mean, as it's called, a suspension bridge. You've got to build the thing from which everything is suspended. So up we go then and see the bones of this thing.
Yeah.
There's a fair breeze that blows up the gorge.
Up the gorge, there is, yes.
That boat chugging up there.
I know.
It's very picturesque, isn't it?
It is.
It's a very pretty little natural wonder on the edge of a city.
It is. Well, this is actually where I started climbing.
Is it?
And it's where I went to school.
You're a Bristolian?
I am, yeah. Yeah, this bridge obviously just holds lots of memories for me, having seen it from a very young age. And
Fancy that.
Yeah, it's really cool for me to be up here now.
So this is your stamping ground?
Yeah, it is. So Jonathan, when they were thinking of building a bridge across here, why didn't they just go for the traditional big stone sort of aqueduct type design?
In the 18th and 19th centuries,
Yeah.
Bristol, its goods were being carried in the great sail ships,
Oh yeah. Of
clippers,
course.
those boats.
Yeah.
So if you've got broad sails and in particular tall masts,
Yeah.
then you'll need something like 100-foot clearance from the water.
Okay.
So you need very broad, very tall arches. So I think stone was out, too
Right.
bulky, too expensive, too big,
Yeah.
and iron was in, but iron was still an audacious leap forward.
I have to say, I'm really enjoying being up here.
You are? Now, a suspension bridge is a fairly simple shape, but it's juggling with some fairly elemental forces, and it works more or less like this. I'm going to put in 2 towers first. That's the sequence that they were built in, after all. Okay, so there are 2 towers. And the chains go more or less like that. And then there are rods coming down from those chains. Now, those rods carry what they hope to be a fairly flat deck. The problem is there's enormous force down there trying to make this lot sag. And so, to either side, there are more chains which are anchored into the ground like that. So the force which tries to come down here and sag down into the middle is held back by these forces, creating an equilibrium which is balanced on each of these towers. So this position here is really important in each case in holding the whole thing together and stopping it from plunging down into the gorge. Let's away, lady.
Yeah.
There's more climbing to be done.
Good.
We're not going away yet.
By the 19th century, Bristol had undergone a boom in building and population. It was one of Georgian and Victorian England's busiest ports, seeing much of the goods and sea traffic coming in from the colonies of the British Empire. At this time, Bristol's only bridge across the Avon was in the city centre. The only option in crossing the gorge was to take small ferries, but a successful entrepreneur had a plan to change all that.
Well, the original conception was of a local merchant, a man called William Vicks.
And why build a bridge?
The theory is that William Vicks thought it would be useful for the rich and the famous to be able to get to the clean, fresh air of Somerset without having to go down through the docks and the rather smelly hoi polloi of the docks area.
And so a competition was held. What were the circumstances of that?
Well, a competition was advertised and 22 designs were submitted, including 4 by this young man, Isambard Kingdom Brunel. But because of the technology involved, they asked Thomas Telford to act as judge for the competition. Telford dismissed all 22 designs, said that they wouldn't work. And Telford said, here's one I prepared earlier. And he effectively submitted his own design and awarded himself first prize in the competition he was supposed to be judging.
Well, that smells like a bit of a stitch-up. What did Brunel do?
Brunel got the judges together, it's about 2 miles from here, harangued them for 2 days, and they withdrew the original announcement and gave the prize to Brunel instead.
The first part of the bridge to be built were these huge foundations called abutments. Built into the rock of the Avon Gorge, they give the towers a firm footing on which they still stand today.
Because there are no detailed construction drawings, it was thought that this abutment was solid until some routine maintenance work on the pavement discovered a shaft which led down to 12 hidden underground chambers.
Discovered in 2002 after being closed up for over 150 years, these enormous vaults beneath the two towers were built to reduce the cost of construction. It meant that less stone needed to be used without reducing the abutment's strength.
The reason all this is thought to be solid is because a borehole was driven in 1969 to investigate it. It just happened to hit solid wall, and so they thought it was pure masonry. But today, you can come in here and see these grand spaces. Look at it, fabulous. Thousands of stalactites. It's a spectacular thing. And you can see where these man-made vaults meet with the natural rock. In fact, there are 2 vaults here running parallel, and then through that wall, there are another 5 at 90 degrees to us. Incredible engineering achievement. And of course, when Brunel died, the fact that there were no notes, no drawings, meant that the secrets of these spaces went to the grave with him.
Brunel's hidden vaults are around 36 feet in height, but are linked by tiny holes only just big enough for a man to crawl through. But in 2002, the first man to come down here in over a century and a half took a slightly different route in.
John, what happened when you discovered these vaults?
It was around about sort of March time. I was told from the Bridgemasters to come and survey the shaft. As I turned the shaft and looked through the hole, I had a powerful head torch on and saw sort of this blackness and then my light going through. I thought, wow. And then crawled through and there it was, sort of the first of the chambers.
And what did you think when your light fell on these great vaults?
Yeah, it was just amazing. Every time we found a new chamber, I thought, blimey.
So was there anything left by the builders?
Nothing at all, which is really disappointing. We really hoped to find some stuff, but except for the nails, that was it. Nothing whatsoever. It was completely clean.
Brunel completed these huge abutments in 1836, but it wasn't plain sailing from here on in. Buying the iron chains needed to span the gorge blew the budget, and a disappointed Brunel had to call a halt to construction in 1843.
This bridge will always be remembered as one of the seminal monuments to Isambard Kingdom Brunel, but few realize that it was completed after his lifetime, this structure that he called my first love, my darling. When he died in 1859, building work had stopped for some 16 years. And it was the Institute of Civil Engineers who appointed 2 of their number to complete the task. Enter Messrs. Hawkshaw and Barlow. It was they who managed the completion, who oversaw it, and who ensured that Brunel had a lasting legacy in this bridge.
It took just 2 years for Hawkshaw and Barlow to complete the bridge. And 33 years after construction had begun, Brunel's dream of a suspension bridge spanning the Avon Gorge was finally ready and open to the public. The bridge was originally intended to carry only light horse-drawn traffic. Today, largely unchanged since the 19th century, it carries over 4 million cars a year. For the next climb, we'll be scaling the Clifton Tower, gateway to the Bristol side of the gorge, to see how a Victorian technological innovation made carrying all that weight possible.
What I want to see up there is to see a saddle.
Uh-huh. Okay.
Sounds unlikely.
Right.
Bridges have saddles.
Do they? Another place for you to sit.
Bridges like this do, because there are 11,000 cars a day come over this bridge.
Wow.
Which is incredible, isn't it? And much more than Brunel ever imagined.
Yeah.
But the reason they can take the load is to do with this saddle.
Okay.
So I think it's worth having a peek at.
Definitely.
Yeah.
I'm intrigued.
How high is it over the gorge?
From the actual bridge level, about 250 feet.
Well, this is going to be the highest climb we've done then, in that case.
Yeah.
Yeah.
Wait.
It's getting a little bit windy now, isn't it?
It's picking up.
At this sort of 10 foot off the ground altitude.
Suddenly, we're in the wind zone.
It's a tad moist.
Well, yeah, it's Bristol.
It is.
What do we expect?
You've got to embrace that West Coast atmosphere, haven't you?
Yeah.
Hey, tell you what, while we're here,
Yeah?
you want to pass the time with a little game of Spot the Difference?
Okay.
Because this tower is different than that one in a few subtle ways.
They look identical to me.
3 big differences. I'll give you one, okay?
Right.
Because you can't see it from here. On the sides, the sides of this one
Yeah.
are scooped out by these arches,
Yeah.
but they're solid in that one, okay?
Right.
That's just one difference. 2 more.
Okay. The top, something to do with the top?
See the arch?
Yeah.
It's much more pointed on that one.
Ah,
That's much more like a Gothic-y arch.
right.
This one is rounder. But there's one really clear difference. If I slap the corner there
Yeah.
and give you a clue,
That's a good handhold.
yeah, is that
Got
what
a
it's
nice sharp arete.
called? You climber. And what about that one?
Ah, yeah, I can see. It's looking a bit more sort of a flat surface.
Isn't it shaved off?
Yeah.
It's a chamfered corner. 45 degrees, diagonal slice off the edge. Less of a good handhold for you.
No, that wouldn't be good.
But it gives the tower a different profile in each case. From a distance they look the same, don't they?
Yeah, totally.
But they obviously learned from them as they made their way upwards.
Yeah.
And you can see, look, big joints in the masonry right the way down to the floor,
Oh,
where
yeah.
bits have been added and they changed their mind. And
Huh.
all right, the rain's setting in, Lou.
Right, should we find the the saddle?
Yeah, let's get in there.
Tell you what, even though it's raining, we've actually got quite a nice view.
It's a heck of a view, isn't it, over Bristol?
So is this the saddle?
There it is. Look at that beauty.
That's amazing. It's massive.
Yeah. It should, what I understand, is it makes your ride over the bridge more comfortable. Exactly how, I need to find out.
Okay.
So I'm hopping in.
Even though Brunel didn't complete this bridge, this saddle, as conceived in his original design, was essential to making this pioneering structure work.
So, David, what exactly is a saddle?
This saddle is an enormous piece of metal. It's a combination of cast iron and wrought iron plates, all bolted together. Sits on top of the tower, and it connects the chains which come up across the gorge with these chains which come up from the anchorages. And all the weight of the bridge and all the traffic loads on the bridge, they're all transferred up the chains to this saddle, and it all bears down on the top of the masonry towers.
Now, this thing's got to cope with forces from different directions. How does it manage to do that?
Well, it's ingenious method whereby the whole thing sits on a bed of rollers. That allows the saddle to move towards the river or away from the river, depending on the tension in the chains. So, for example, if more traffic comes onto the bridge, that increases the tension in the chains on that side. It pulls the saddle that way until the tension in these chains is increased so that they're balanced.
That's a very clever solution. Was it always part of Brunel's design?
It was very much part of his design. These saddles, along with some of the chains, were in use before they came here on one of his earlier bridges, being the Hungerford Bridge across the River Thames in London. And all of the rollers, the base plates, it all came from that bridge.
Things look a bit brighter now, Luke.
We have a break in the weather.
We do.
Finally. That was really grim. But hey.
So
we
now,
coped.
let's have a look at how this thing's held up then, shall we?
Yeah.
These chains.
This is probably the smallest climb we're going to do in the whole series.
Is it?
But it's going to be fun, because we're going to be sitting right on top of the chains.
But I've found, actually, that the shortest climbs can be the most technically difficult.
Yeah. So we got to sort of sidelong our way across a little ledge and then get onto the chains.
All right?
Okay.
This couple of feet looks actually quite perilous, because beneath it there are about 300 more. Now, Lou, that had better not be skiddy after the rain, else you're on a ski slope, girl.
I tell you what, it's dried off surprisingly well.
What's it like, Lucy?
It's cool! I'm on top of the suspension bridge. This is amazing.
Okay, Lou, so my handholds are here.
Yeah, big handhold. And you're just traversing along. Well done. When you feel comfortable, you can grab the chain.
I'm not sure comfortable's the word.
You see those gaps in the chain? You can stand on
like
those.
that?
Yeah, that's it. Brilliant. You can come down here if you want, or just stay up there, wherever you feel comfortable.
Well, there's a place for a picnic. It's great to see this, though. I mean, it really is. You don't get this close up to the real structure.
It's an incredible sweep, isn't it?
Yeah, it's beautiful. It's a great, sweeping, beautiful thing. It's amazing, isn't it, how this long after it was dreamt up, it still seems an amazing achievement. The story of these iron chains is ironic in itself. Brunel designed the bridge to have 2 parallel layers of them, and they were manufactured, but when work ground to a halt on this Clifton Bridge in 1843, then they were taken to another bridge at Saltash, the Royal Albert, used to link Devon to Cornwall on Brunel's Great Western Railway. In 1863, after 20 years of inaction on this bridge, the timber rose and new iron was sought, and the new engineers, who were Hawkshaw and Barlow, sourced it from London, in fact from another Brunel bridge, which was Hungerford. Now they brought it on, guess what, Brunel's Great Western Railway to Bristol, Temple Meads and then to site. But isn't it remarkable? It was not only brought from another Brunel bridge, but carried on Brunel's railway. He carried on supplying this site with what it needed even beyond his death. Now that's remarkable.
How are you feeling up here, Jonathan?
I'm really exhilarated.
Are you?
Yeah.
Well, did you know that this is the highest point we've been to so far?
Is it? I
On
didn't
any
know
building.
that.
Down to the high water mark. We're at about 320 feet here.
It doesn't quite feel that high until you start to look horizontally, and this is what I think is so fabulous, because you just see blue hills beyond you, don't you?
Yeah.
And you look over an entire city. And it's such a wonderful vantage point.
And now it is time for us to upside down.
All right. Okay, should we go?
Make the most of it while you can.
In 1998, this new mechanical gantry was hoisted up from the river and installed. It allows for maintenance to be carried out to the underside of the bridge. Lucy and I are making our way down here so we can climb out and get a good look beneath this marvel of engineering.
This.
That's a heck
it's
of a
not
gantry.
scary. It's not scary.
Yeah. It's a good
Wow.
broad base from which to work on, isn't it? Now what are we going to do? Tell me.
We've got these Tyroleans set up.
Yeah.
So we're Tyroleaning
That's easy for you to say.
across this quite long drop and getting a very close view of the underside of the bridge.
Yeah, we can really see the deck from under here, can't we?
Absolutely.
If we get across.
And then we're going to be abseiling basically straight down this cliff face
Are we?
on top of the road. I think this is going to be quite a test for you,
Yeah.
Dr. Foyle. For both of us. It feels like we're in the mountains.
Yeah, I've got a mountain sense of doom. So what do I do? Just clamber over the edge?
Yeah, so you can kind of just lower yourself down onto the ledge that's down here.
All right, you ready?
All right, should we do it?
3, 2, 1.
Woo! Wow.
Beautiful thing. That's a beautiful thing.
Oh, wow. It's an audacious thing, this bridge,
Isn't
I have
it?
to say. When you're looking at the drop we have below us.
Well, you can see here the whole of the underside of the bridge, and it's rather a more complex structure than meets the eye. It looks very thin when you see the bridge from a distance. But in fact, you've got several layers of construction. You have first the longitudinal girders, There's one running right above me, goes the whole length of the bridge. And that is what the rods are attached to, which are in turn carried by the chains. So that is the primary suspended element. And then from the longitudinal girders come these trusses. They're beautiful lattice work things which curve at each end. And it's these which carry the basis of the deck. So the timber deck then is held by those ultimately. Now, all of this timber work looks fairly new, and in fact it was replaced about 50 years ago. The Victorian bridge similarly had a timber deck. But when you think about the vehicles of the Victorian age, horses, well, of course, their legacy was leaving manure on the bridge, which rotted the timber. I hope these are rather more secure.
So we'll go along and we'll get onto the abseil ropes now. Should we descend, Dr. Foyle, seeing as we're here?
Shall we, madam?
Let's do it.
Together, you and I.
All right. That is a view and a half.
But that actually brings home, doesn't it, the audacity of taking on a project like this.
It does.
You think of a factory full of that ironwork, and someone's saying, yep, you're going to put it where? 300 feet in the air. You
what?
crazy.
Totally amazing. Oh, wow. Look at where we were. It's amazing.
That I enjoyed.
Oh,
That was great.
yeah.
Lucy?
That was awesome.
Yeah, that was a really unusual view of the Clifton Bridge. Well, I really enjoyed that, and I'm pleased we fitted the Clifton Suspension Bridge into our roll call of 15 great buildings, because although some other bridges are bigger, like the Humber or the Severn, well, they're the great-grandchildren of this bridge. And the way it gloriously leaps across the Avon Gorge makes it spectacular in a way that no early bridge is. Nothing can compete with this. I think it really is one of Britain's great buildings.
Next time, how the Victorians' expressed desire for all things Gothic led to Britain's most spectacular railway station, St Pancras.
And Climbing Great Buildings continues here on BBC HD tomorrow at the same time. We're off to the Museum of Life at 8. Next tonight, it's The One Show.